Lesson 89, Identifying Characteristics of Quadratic Functions. If you take a look at the graph we have here, you can see that it is a parabola-shaped upside down U. All quadratics are in that format. Has that curve, so there's going to be a maximum and a minimum. So let's take a look at our graphs today. So identifying the vertex and the maximum and minimum. The vertex of a parabola is just the highest or the lowest point on a parabola. The minimum of a function is the least possible value of a function. So if you think about a U-shaped parabola, the vertex is always on the base, where the turning point of the parabola is. So if it's a U-shaped, it's got a minimum. There's the lowest point. If the parabola is the other way around, it's an upside down U, that means the vertex is up on top and we have a maximum, which is the greatest possible value of the function. So below we want to find the vertex and then the maximum and minimum of the values. So the vertex is always the very bottom part or the highest point. So here the vertex would be there. The vertex crosses the y-axis. We're looking for the y value. So the ordered pair for the y value. So when x is 0, y is at a -4. So we would say the vertex is 0, -4. And then the maximum or minimum, this one has a minimum. And we would say that the minimum is -4, and everything's going above a -4. We'd say the minimum is -4. If we were to find the domain and range of all this, the domain would be all real numbers, because every single x value that you put in will give you a y value. But the range has a limit. The range, y has to be greater than or equal to a -4. So this is where the maximum and minimum comes into play when you're dealing with the range. Let's look at the second one, letter B. We have our vertex up on top. So our vertex would be the ordered pair. This is the x is at -2 or +2. The y value is at between 4 and 6, so that would be 5. And this one has a maximum because the vertex is on top. The maximum would be 5. And if we did the domain for this one, again, it's all real numbers. And the range also has a limit. Y has to be less than or equal to the highest point, which is 5. Next one, find the vertex here. Vertex, the lowest point is right there, so that would be at 5 for the x value. Y would be -3. And then we have a minimum because we have a U shape, so we have a bottom level here, so that would be at -3. So the minimum and the maximum is always your y value of your vertex. So if you found your vertex, all you need to do is just take the y value to find your maximum or minimum. And then the domain, parabola shape, so all real numbers. And the range, what are all the possible y values? Well, it's got to be greater than or equal to -3. And so your range is always going to have your minimum or your maximum and your y coordinate of your vertex. So all three of those numbers you will see in your answer. Try another one. Here, let's identify our vertex. So our vertex is right there. So vertex, we have x value of -1 and a y value would be -2, -3, -4. Then we have maximum. Maximum is a -4. Then the domain, all real numbers. And then the range, the y has to be less than or equal to a -4. So it's always going below -4. The highest point is -4 on the y coordinate. Next, finding zeros from the graph. Let's define what they mean by zero. Zero of a function just means the value of x that makes the function of x equaling to 0 or y equaling 0. The zeros of a function are also the same as the x-intercepts. And so sometimes you might have 1, 0 or 1 x-intercept. We could have 2 x-intercepts, or we might not have any intercepts. So let's find the zeros from the graphs below. So all I'm looking for is where does it cross the x-axis. So in this case, there are 2 of them. There are a couple ways of doing this. You can look at the graph and determine if it's exact, and which these are. So we could say the zeros, x can equal a -1, and over here would equal a +3. If you didn't have the x coordinates, that means you could take your function, so -x² plus 2x plus 3, make that equal to 0. But we want to make sure that we have a positive x². So we're just going to move these to the other side. So now we have 0 equaling x² minus 2x minus 3. And then we can factor the trinomial. What do I multiply to get -3? But m together gives us a -2. That would be a +1 and a -3. From this point, all you need to do is make each binomial equal to 0. If I subtract 1 on both sides, I get x equaling -1, which is what I have here. Right here, add 3 to both sides, and I get x equaling a +3, which is what I have here. So the zeros are -1 and 3. This next one crosses the y or the x-axis right here. The vertex is the 0, so I just take the x-coordinates of our vertex. Since our vertex is -2, 0, we would say that the 0, x would have to equal a -2. Again, you could easily factor that. That has the greatest common factor, so I can factor out a 3. That would leave us with x² plus 4x plus 4. And if I factor that, I end up with x plus 2 times x plus 2. Make each factor equal to 0. So if I have just the greatest common factor here, 3 can't equal 0, so I just disregard that 3. And both of these, x plus 2, that would just make it x equals a -2, because you make both of them equal to 0. The x would have to be -2. Next one. Find the zeros on these. So here we have our vertex, but we can't quite tell, is that halfway? That could be -9, but let's just verify it by factoring our trinomial. So we have x² plus 12x plus 27. We have 2 points where it crosses the x-axis, right there and here. So we want to verify it. So let's factor these. What do we multiply to get 27, but m together gives us 12. It's a positive 9 and a positive 3. And then I just make both of these equal to 0. I subtract 9 here on both sides. X would equal a negative 9 on this side. Subtract 3 on this side. We would have x equaling a negative 3, which would make sense because this is between negative 4 and negative 2, and this one's between negative 10 and negative 8. So our zeros are negative 9 and negative 3. This next one, when the vertex is on the x-axis, that means there's only one 0. And this, from the graph, we can tell that it lands on 6. So the 0 for that one would be 6. Next one, here we can take a look. It never touches the x-axis. So we would say no solution. There's no x values that will make that equal to 0. The next one, this one's an upside down parabola. Again, it never touches the x-axis, so this would be no solution as well. Example 3, find the axis of symmetry using the zeros. The axis of symmetry is just a line that divides the figure or the graph into two mirror image halves. So it always goes through the vertex. So we're going to find the axis of symmetry for each graph below. So the first step is to find the axis of symmetry, find the vertex. The vertex is here. And in order to determine that, what the vertex is, we can easily just take our coordinates from our zeros. So you're finding the midpoint between those. So if I take my two x values, negative 3 plus the 5, and divide that by 2, that will give me my x value. And if I take my y, 0 plus 0, divide that by 2, will give me my y value. So negative 3 plus 5 divided by 2 would give us 1. Our y, 0 plus 0 divided by 2 is 0. I was mistaken with that one. We wouldn't have to do that for the y value. We're just looking for the x. So if the x is 1, and so you could, so if x is 1 right here, we can determine where does it cross the y value here. So the axis of symmetry, it cuts the x-axis at a positive 1. So when you're dealing with the axis of symmetry, we're just looking at where does it cross the x-axis. So the axis of symmetry will be at positive 1. Here, the vertex is the 0. So we just have to look at the x-coordinates of the vertex, and we would say that x equals a negative 4.5. So anytime they're asking you for the axis of symmetry, if the vertex is on the x-axis, the axis of symmetry is the x-coordinate. If it's not, you just take the two x values of your 2 points, if you know the zeros, and find the average. So add the 2, divide by 2. Next, the axis of symmetry. Find the axis of symmetry in these graphs. So I have 2 points, my two zeros. So I take my negative 8 plus 3, divide that by 2, will give me my x-coordinate of my vertex. Negative 8 plus 3 is negative 5. So we have negative 5 divided by 2, so negative 5 halves, or a negative 2.5, which would make sense because this is 2, this is 4, the middle point is 3, this is not quite in the middle, so this would be x equaling negative 2.5. The next one, the vertex is here, so I know the axis of symmetry goes through the vertex, but I can't quite tell if it's halfway through, so I just take my two x's, add them together, divide that by 2, and I get 9/2 or 4.5. Next, find the axis of symmetry using the formula. The formula for the axis of symmetry is x equaling negative b divided by 2a. And how do we know what to put in for each variable? This is your a, this is your b, this is your c. Remember, it's always the coefficients that we're looking at. So if I use the formula, x equals negative, my b is 6, divided by 2 times a is 1. So 6 divided by 2 is 3 times a negative is a negative 3. And here's our a, b, or c. So x equals a negative, and then my b is 3, my a, or divided by 2 times my a, which is a negative 2. That will give us a negative 3 over a negative 4, which is a positive 3/4. Next one, a, b, and our c. So x equals the opposite of negative 12, or opposite of 12 is a negative 12, divided by 2 times our a, which is 3, so give us a negative 2. Here's our a, b, and our c. X equaling a negative, so I'm going to just take the opposite of 6, which is negative 6, divide that by 2 times a negative 1, which will give us negative 6 divided by negative 2, which is a positive 3. So that formula can make finding the axis of symmetry pretty easy, especially if you don't have a graph to look at. You just have to use that formula to solve. And let's take a look at some application. A golf ball is hit from an elevated platform 10 feet above the ground. It starts with a vertical speed of 160 feet per second. Ignoring friction, the equation y equals negative 16t squared plus 160t plus 10 gives the height y as a function of time t. Find the highest point the ball reaches and how long it takes to reach it. So for this one, we're actually trying to find the vertex of this parabola, because your y value or your x value is going to be the time it takes to reach the highest point, which is your y value would be the highest point. So if I take my function here, and we can use the formula. So this is our a, this is our b, and this is our c. So to find the x coordinate, our axis of symmetry, where is it across the vertex? We would have the opposite of 160 divided by 2 times a negative 16. And so I have a negative 160 divided by a negative 32. I would get x equaling a positive 5. So it takes 5 seconds to reach the highest point. But what is the highest point? So now I can just take that 5 and plug it in for t in my equation. So I have y equals a negative 16 times 5 squared plus 160 times 5 plus 10. So it's negative 16 times 25 plus 160 times 5 equals 400 plus 10 will give us a total height of 410 feet. So our ordered pair would be 5 and 410. After 5 seconds, it will reach its highest point. And our last one, a chunk of lava flies out of a volcano from a height of 12,447 feet at a velocity of 608 feet per second. Find the highest point the lava reaches and how long it takes to reach it using the equation negative 16t squared plus 608t plus 12,447. So So let's find out the time it takes. So it's A or B or C. So formula x equals the opposite of our B, 608, divided by 2 times a negative 16. Now we have negative 608 divided by negative 32. That gives us 19 seconds. After 19 seconds, let's see the height. So negative 16 times 19 squared plus 608 times 19 plus 12,447. So negative 16 times 19 squared plus 608 times 19 plus 12,447 gives us a height of 18,223. So after 19 seconds, the height of the chunk of lava is at 18,223 feet. So that's our lesson today on identifying characteristics of quadratic functions.